What I'm going to explain to you today is a brief description of what actually happened on the ground from a physical perspective. You've heard plenty from, or you can hear plenty on this site from people who were there and witnessed it firsthand. This is a little bit more of an antiseptic or physical approach to what's going on, so you can understand the energy and the way the bomb blast actually worked. Both the bombs, the Fat Man bomb dropped over Nagasaki on August 9th, and the Little Boy bomb dropped over Hiroshima 3 days before that, had comparable amounts of energy when they were produced in terms of blast, and we'll get to that in detail. But what people experienced on the ground, completely unexpected, when both bombs went off, was an instantaneous fireball first. That fireball had expanded to over 60 meters across in less than a second, and rapidly expanded from that point on because it's going the speed of light. So that's something you couldn't even perceive in terms of the speed that it's expanding. The blast shattered windows up to 16 and even more kilometers away from ground zero where the bomb was detonated. And it could be felt, the sort of vibrations from that explosion could be felt upwards of 60 kilometers away from the hypocenter. Fires were started, obviously, immediately at ground zero because the temperature rocketed to the temperature of the surface of the sun within a matter of fractions of a second. And fires, anything flammable, ignited up to about 3 kilometers away from the hypocenter. Anything that was within a kilometer or a little bit less of the hypocenter was immediately vaporized because those temperatures are so high that they'll turn anything into a gas. Fundamentally, the bomb leveled several square kilometers of the city, depending on the city, and we'll talk more about that a little bit later. And the destruction was felt instantaneously, ultimately resulting in over 100,000 deaths in Hiroshima and close to that number in Nagasaki. The bomb itself, in detail, over both cities, underwent the same process. So initially, when the nuclear reactions are started in the bomb, when it's detonated about 2,000 feet above the surface of the Earth, it initiates a fireball. That fireball spreads in a sphere away from that detonation center, which is, like I said, several thousand feet above the ground. That sends out a shock wave and a heat wave in a sphere. So obviously anything above it isn't affected, but everything on the ground is seriously affected by the energy that's produced by the bomb. That expansion of the sphere of both blast and heat, and we'll talk about what those mean in a second, is so fast that it forces most of the air above or around the bomb away. And so what you've done is you've produced a vacuum. And when you produce a vacuum, you have to unproduce a vacuum. And that means that you've pushed all this air out from the blast, and then all of a sudden this air is going to come rushing back in to fill the vacuum, and it's going to rush right back into the point where the bomb was detonated, and all that air is going to run into itself, and it's going to be forced up because it has to go somewhere. And that's what produces the mushroom cloud that you see in any kind of atomic weapon test or atomic weapon detonation. And so that mushroom cloud builds and builds over the ensuing time after the bomb has been dropped, but it is directly the result of the blast pushing out and then sucking back in. So the energy from an atomic weapon is dissipated, or it's produced in 3 ways, and this is how it differs from a conventional weapon. Like most weapons, it produces heat and it produces blast. It was about 50% heat, these are 2 atomic weapons in 1945, 50% heat and 35% blast. But it also produces radiation energy, and that's how it differs from a conventional bomb. Both bombs produced a total energy equivalent to about 20 kilotons worth of TNT, so that's 20,000 tons of TNT if you could have found a way to detonate it all in one place and all simultaneously, which would be virtually impossible. So let's